So we are again, well, let's see if we can do it quicker this time. Maybe I already will start the question with some easy question. Is there currently in academia maybe too much research going on still on the fully supervised setting? Shouldn't maybe all the research consider some unsupervised or semi-supervised components where we use unlabeled data? Or does the development, do you improve in supervised learning automatically translate to what we need down the road if we're going for also unlabeled data? Holger, I see you. No.
I think these are orthogonal dimensions. So some people just want to improve the method with the standard data set, just tune the actual method. Another one is then we have these very, very big companies like Google and Facebook and Amazon training maybe foundational models that will hopefully help everybody, or better backbones or something like that, which usually are out of reach for PhD students, so probably they cannot even compete there. And then there are these more data efficient methods, which I actually think at least some topics like weakly supervised learning, for example, are mostly academia favorites. And then there are some topics, maybe semi-supervised learning, that companies like because they solve their problem. I think it's.
So is this an agreement or?
Makes sense to me. I'm not so well versed in the machine learning itself because I always dealt with data. But one thing which I see rarely is the actual active learning. Like this idea that I need to know what is the next sample where I want some information about and what information do I want. I think that's largely untackled from what I'm seeing. I'm not super deep in the research, but I don't know, maybe you have a comment on that. So, no, the audience, no active learning happening in the community, like real active learning.
Well, anybody here thinking of, or maybe to another point you mentioned, if I understood correctly, that the weekly supervised learning aspect is especially in academia, academic favorites, but not maybe that interesting in industry. Maybe can you comment on why do you think it's the case?
I guess the industry is probably driven by cost, and you can always label 1,000 images of something for not too much money, right? And then you get started, then you're already basically in semi-supervised territory. So I think from a very pragmatic viewpoint, industry doesn't need to start from zero, basically.
But isn't there also like a bias in representation? So for example, when we think of people doing actually research, it's often, as you say, PhD students, they have to publish papers, they are getting forced by their professors to have a CVPR publication, an ICCB publication, whatever. Maybe an IB publication is also fine, but it would be better to have a CVPR paper. So in the end, basically, even if you wanted to do something that has an actual application, you are forced to do something more academic, more, I don't know, that gives you something on a leaderboard. And that is not just, okay, I'm much more efficient, I'm faster, I need less energy, but I'm just worse in performance, I'm not reflected on the benchmark, I don't have a chance to get a CVPR publication.
That's a great point. Actually, if you think about, you have a 3-year PhD and you have to write 3 papers, the project size is 1 person year per paper. So you cannot do anything that's much larger unless you're in a big place.
You have to write 6 papers.
6, yeah, of course, like for every CVPR, right? And every ICCB. So yes, yeah, I think this is a real problem. And also, if you look at the 30 people working for so much time just to create a data set, which is then used, it's a big topic. So I think this is another bias. That's true.
I think another thing is also, I mean, I have shown you in my talk that we try to get early into the test vehicle, integrate it and develop it in the real world. This is also what you do not see in academia, not so often at least. You just take the data sets, you try to develop the method, and you get it published if you rank first, or at least top in the benchmark. But to be honest, if you just use the data set, you just develop the 80% solution. So the real work starts when it comes to the real world, to the test paper. This is also not so much encouraged by the conferences, I have the impression at least. So showing some system or some system integration, not so much. Encourage them developing a new method which ranks first. Even for it's still good work.
But also not only by the conferences, but also by the companies, right? I guess Bosch is similar to Mercedes. They don't want to really show everyone what they have right away.
Yeah, but it's also more difficult to publish such kind of work.
Yes.
Is my impression.
Well, actually, I like this. I talked to Hilde Kühner about that, and I had the same argument. And she said, well, it doesn't matter. Research has a different purpose. It's to create the first, to deal with the first 80%. And then people start making money off it. So, so it's, and also I saw the HoloLens, for example. I was really amazed by the quality of the tracking of the first HoloLens, which wasn't seen in research, right? So these second 80%, so to say, were really done by really good engineering, and I was really amazed at, and I'm sure there was much more manpower than just 3 person years for a couple of PhD students, right? So I think it's also more work and more effort and more money needed for that. So
I think a related aspect is also, if you don't compartmentalize it and only look at a subset, how are you going to evaluate?
yes.
Like if I do a data set and the method and the evaluation and everything by myself, how as a hardworking PhD student, you know, how are you going to evaluate? You need so many metrics.
I don't know how Andreas actually did it. It's like, it's crazy. He did really everything over many years and it worked out. Yeah.
Okay, maybe a question from the audience. Did somebody? Was I from another?
I have some questions. I think the UCS-based UPlan is less dependent on the HTML than UCS, am I right?
I guess it depends on what application you have in mind. So both come with an HTML of like very similar type.
It means that their point of view, some companies like AIMO using HTML, but the other hand, Tesla do not use HTML. So UPlan less use the HTML. So what kind of technique we are doing, I think. So something like a features length. So at the features length point of view, we needed some multiple viewpoint of images at the same time. So in this point of view, and UPlan is not the same.
So I think actually UPlan comes like in the sense of very detailed maps. It's more a question of whether you want to use them. And I just came from the other workshop, which was about reducing the dependency on maps. So I think that's definitely a goal. You don't like the level of maps of map layers there is probably not efficient. Like 13 very accurate centimeter or so accurate layers. That's probably too much if you really want to scale to level 5 automation, drive everywhere. So maybe 1 or 2 or 3 types of semantic layers is enough.
Oh, so maybe to make this question a bit broader and also here in the context. So that's an interesting point. Maps are still a form of human annotation, and if you need them for your day-to-day operation, will this be the case, or do you think there might be some opportunity here as well for unlabeled approaches? Should we reduce indeed the reliance, as Holger maybe now has been voicing as a potential direction? What do you think, Daniel? Maybe?
I think generally it would make more sense to bootstrap in a way that I train a model with little data, I predict, and then I have a very thorough way of fixing the data. So I can actually loop on the data set. And I think that's the thing. There shouldn't be one static data set and then everyone uses it. It should really be a dynamic in a way that whenever there's an error found in the data set, someone fixes it. And if you think that way, that you have the algorithm in the loop and you create new data with the algorithm, and you maybe find typical problems like, I don't know, fire hydrants are detected as pedestrians, something like that, that you then say, okay, now I have a fire hydrant flag, like I do a fire hydrant detection. And then you incrementally build that based on the output of existing algorithms. So you never have to label from scratch. The only risk is that you bias the result, because if some algorithm creates something, you create this echo chamber effect. And so the idea really should be that you somehow need to make it clear that when you do the quality assurance or you repair the data set in the end, that you repair it in a way which is taking advantage of this ability of humans of making sure that there is no bias in it. This is not systematically wrong.
Claudius, maybe some.
I actually like the idea that you generate classes or semantics in the form that it helps the models, like the fire hydrants. So if we would generate a data set now, you wouldn't think of labeling fire hydrants just because the model needs it to distinguish them. Maybe there are even more out there. So we're always thinking in how we interpret the word and what's best for our case, but maybe for the model it's different. Other semantic classes might be valuable as well.
Yeah. And I think this problem with the rider versus biker thing or something like that, it's a bit like that, because you could ask, this idea with this ontology that you ask questions, and then you have this vector, this feature vector of possible properties, and you can map them with the bijection on classes. And you can, by just adding one more attribute, you can potentially create like a power of new classes with that, and then incrementally change your taxonomy by just exploring the edge cases of your data set.
So you seem to all agree here, also all with industry experience and large data sets. So I imagine that this is to some extent happening, of course, in industry. And then as an academic, I'm thinking, so we're not really doing this in academia, right? And that, is it because we are in these different TRL levels and it's not really needed? Or is this, you think, something that's missing in that we are so focused on these few benchmarks that are very valuable, but should we do this more often, revisit data sets, fix them?
So I'm actually skeptical for academic purposes to repair a data set, because then the numbers, will change over time. So everything gets better.
Yeah, but bias is a bad thing.
Yeah.
I was actually thinking, like, maybe we should look at the ECP data set and see how many errors are there, and what's the sensitivity? What happens to the ranking if you fix these errors? If a lot of things happen, it's a problem. If nothing happens, then it had the right level of quality for this purpose. So I actually like the idea of at least verifying.
The idea is nice, but if you practice when 80% today is not 80% tomorrow, right?
Yeah.
And I think with Kitty, there were some issues. I don't remember. I think it was related to the metric. At some point, they had to rerun all of the results. So I think also with MAP, we saw that in the beginning, people had 11 recall points, and nowadays it's 50, 40 or something. Yeah, something like that. Yeah, 40. Because people just realized the metric was very random. So I think in practice, it's very difficult to do.
But I think it's a reality, and that's a problem. Reality is always about statistics. There's no hard ranking or anything. And that's the whole, I think that's the problem of academia, that you need a ranking so you can get your paper out and you get your PhD thesis. But at the same time, you need to be a bit more holistic, and you also want to be able to perform in a different domain. Like you can say, like this actually happened a lot with Kitty. I was like, how fast is the algorithm? That's actually something which adds a new dimension and which makes sense. And there are other dimensions and other metrics. But I think like there was recently a paper about the quality of ImageNet, I think. How many, like I don't know the numbers, so I don't want to say anything, but there was a pretty high percentage of errors, and it's really problematic. And in ImageNet, it's even more problematic because it's arbitrary classes, the same as Cypher. It's also a big problem. You have, like, if you look at the class descriptions, like there are different kinds of animals. I don't even know what kind of animals they are. And how should a computer differentiate them on like a couple of pixels? So the ambiguity in this data and the disagreement annotators would have is so high that a human would never perform well on this kind of thing. So I think it makes sense to track at least the process on the one end and the quality in a way that you say, this is roughly what we guess is the quality. It doesn't have to be super accurate.
We actually just had a very interesting talk in the other workshop by Matthias Rothmann, who presented a method about automatic label detection in automatic label errors detection in a semantic segmentation data set. So that's also something that might be interesting related to that topic.
Totally, and I think there's also more research lately where people really look in trying to automatically find those errors when you have label errors or something like that, yeah, or classification errors as well.
I believe there was a question here.
Yeah. I was just thinking to a question that came up to my mind. We are talking about data, no? How to build richer data, bigger data, more quality data. But actually, do you think that being able to generalize is just a matter of having a better data set, a richer data set? I mean, I was thinking to that because just an example, I've not been trained to drive in Manhattan, but actually did. So do you think is that generalization is just a matter of data, or maybe it's in order to build more general models, we need to think also about experience that for me is not like being able to generalize in all the scenarios. So experience is something for me and generalization is another thing.
I have some thoughts. We'll see you going around. So, Claudius?
Yeah, I think there's still missing. I mean, perception is still some kind of template matching, also recognizing the things that you have shown before, but there's not some higher cognitive skill where you can match something new to what you have seen before. Say, well, this would behave in that way or that way. I think this is still missing a bit. Yeah.
I also think so. I think data set quality is one aspect. The machine learning, of course, but this is pretty fun. It works pretty well in these type of tasks. But then what I said earlier with problem quality, do you even ask the right questions? And all of these ideas with one-shot learning, where you say, I have a couple of features which I already have, and then I put a fully connected layer to learn something new on top. That's super intriguing, because this is a little bit like finding these higher concepts or these more like reasoning type of questions. Like, if I know that this thing seems to be alive, then I might react differently, and this will directly impact planning. So being able to train a machine to do that is maybe more valuable than finding 15 different classes for pedestrians and animals and pets and whatnot.
Yeah, I would also say that it's important to find the right metrics, as you said, to decide what you have to detect. So currently our metrics or our data sets, you consider all pedestrians equal. It doesn't matter whether they are 50 meters away, 100 meters away, or directly in front of the car. Of course, it matters whether this is the case. But it's difficult to boil it down to a single number. So that's why there we also need some new approaches, new solutions that try to cover this, the relevancy of those different objects and what has to be really protected.
That's also an important point. Whatever you do, the severance, the severance of the error the system can make needs to be part of the metric in the end. And I think this, as a general concept, is super important and is much under studied in a way.
Holger?
Yeah, to that point, I think it's a bit like reinforcement learning, in that the true thing is really just, did you kill somebody or not with your car?
Yeah.
But it's so far away that, and you can test it, that's the other aspect, that you cannot work with that. You need some proxy metrics, and you just hope they are somewhat correlated, but they may not be that
You need to
correlated.
back propagate them somehow.
Yes.
But is that not something that you can solve with simulation? So how would you rate the role of simulation for versus generative models and combined with generative models?
Very interesting question. I always think that simulation, like, it is also handcrafting. Like, or it's like creating a data set also. Like, you're going out there, you have certain design criteria, and then you're collecting data. Simulation is kind of the same. I haven't seen any simulation that is not heavily biased towards a particular use case.
Like 50 cars in GTA or something like that.
Yeah, but especially the spiders in a particular use case might be interesting when you think about rare cases, right? We had this talk from Anima Anand-Kumar in the last workshop. She basically heavily created those rare scenes where you have road debris on the road and yeah, rare objects on the road, which you could not find in real data, or really rarely find them in real data. And she showed basically the performance is going to be much improved, especially on this use cases. So would that be, in your opinion, a solution, especially for the rare use cases then?
In my opinion, it helps, at least in some use cases. I mean, you mentioned this lost cargo use case, which does not occur so often. And if you can generate synthetic data for such use cases, sure it helps. Definitely. So you need a mix of both. So I don't think that synthetic data alone will somehow work. So you still need realistic data, real data, but it can complement it and add some value, especially for those rare cases.
I do agree that it helps, but I feel like you can only simulate what you can name. Kind of, if you haven't seen it before, you won't be able to simulate it. So I feel like the solution is maybe more to separate like geometry from glass, for example. Just learn that there's something there, and then in the second stage we can add semantics to it. But you should avoid any obstacle and not just the ones that you had in your training.
I think one concept, there was a paper by the IIT a while ago. They took the idea of hazards in operations from process engineering. And the concept there is that you have all of these elements, like for example, objects you cannot pass through or something like that. And then they say, okay, what are the modifiers? What can you do with it? Like if you think of a camera, it has a lens and there's light and so on. And for each you can have too much or too little. And then you really do a combinatorial search. And it's actually happening in process engineering. You have this huge chemical plant with thousands of valves. And they think about what happens if too much goes into this valve. Will the plant explode? And that's actually because plants actually exploded. So it was necessary. And there are standards around that. And I think that's something you could have, particularly in the automotive industry, where you really have a consortium of people doing nothing else than combinatorically thinking about cases which can happen, which you can then simulate. Because that could actually get the tail out, right? Where you can actually map it out somehow.
And maybe also the measuring part, right? Because indeed, if you keep adding all these cases and you go, oh, here's one, and here's one, and then you keep adding to the training data, and then maybe you get some system that works, but you might have some form of overfitting on these cases, right? There'll always be a gap. But would it be an idea to have these kind of ideas that you only applied in the testing case, in the validation data, that you can at least measure when you start to overfit? Is this maybe a use case for simulation? And well, maybe ask Holger, who was skeptic.
Yeah, I'm reminded again what you said, what we also experienced, the NCAP use case, where you test on fake pedestrians and they don't have much in common with the real pedestrians.
But it's a diversity question in general, right? What's the distribution you need to draw from? Do you really draw from the real world distribution? Or do you unbalance it purposefully in order to make it more fair? Then all of the fairness question comes in, right? And fairness can be anything, right? Do I write over this animal or over this kid? That could be one thing, but there are much more subtle things in fairness. Like, what do I really need to make a data set representative? I think it's largely unstudied. Like, nobody knows. You just have a gut feeling. When you say like weather, for example, right? Of course, weather. Is it the location? Do I train if I'm in California, I train on pedestrians, it won't work in Norway in winter, of course, right? That's easy, but there are so many things which aren't discovered. ECP, that was super interesting. The ECP data set, they tested Eastern European versus Western European cities, and there was a significant difference between the two, which was super surprising for me, because for me, these cities all look alike. So that seems to be a lot of difference, actually.
There was somebody who wanted to.
Oh yeah, the discussion moved on a bit. I just want to comment on what you said regarding the severance of different kinds of faults, because if you think that through, in the end, what you can then only define is
performance metrics for, say, an image detection or something, if you relate that to, well, your specific application that you have in mind, which makes the whole process even more complicated in the sense that, well, there is no image detection for automotive cars. There's image detection for, say, a parking system or an ECC. And well, we had this discussion a while ago in our department, and the biggest problem now is how do I communicate that? How do I put that into KPIs that I can communicate to any kind of OEM and so on? So it's I personally think it's definitely necessary, but well, it increases the amount of variables you can put into your system, in a sense that even the way how you measure how good you are, and I mean, this somehow relates back to the discussion about the data set, in the sense that, well, what kind of data set do you want? Well, we want a data set that in the end lets us build a product that during deployment does its job for, well, lack of better definition. And this is a bit tricky to define in that sense.
Completely agree. Yeah. And then it gets interdisciplinary. And if I've learned one thing during my research, it sucks. If you do interdisciplinary research, it means you're never in the right community. You cannot publish it because everyone says, oh, it's object detection. I don't do object detection. And yeah, so it's, and in the company, it's the same problem, right? You have to talk to other departments and they don't talk to each other. Same problem.
Yeah, so it's not only for company. I mean, I'm a tier one, so
and then it's
your OEMs, or you have to choose in addition, and things start to get messy at some point.
Exactly. But it's necessary. I agree. It needs to be solved.
And I think we often talked about like finding converging to that one solution across all companies. Let's say, I think there may be different companies that want to offer different solution, right? The Porsche could look different from the Volvo autonomous driving, and the Tesla obviously as well. So I think it depends on the user.
Yeah, but they have to adhere all to the same traffic standards, and
but if we just trade off like you know, speed versus safety versus comfort.
Yeah, or maybe you have different algorithms. Like if you say, I have a lot of false negatives or false positives or whatever in the detection setup in the after perception, maybe the system after that is super robust against that, and you have really created the best system in there. Well, how could you correlate these metrics as a standard? And that wouldn't work.
That's actually the case. I mean, there are different applications which more require, or which can work with more false positives, or
When sometimes it's
so
like emergency braking is particularly tricky.
do it differently depending on the application.
Yeah.
That's why I think such a general metric like mean average precision is cool, because we can all compare each other, but we have to keep in mind that it's not sufficient.
It needs to be correlated. That's the one thing, right? And if we can all assume it's correlated, at least loosely, we are already better than having nothing. And yeah, that's maybe the trade-off to be made.
so I think there's not that much time left, but I've sort of one pet peeve question here still about if we are focusing in our data sets very much on Western societies, Western problems, right? I think it was nice that you mentioned already the ECP going broader, at least within Europe, which is still a very particular view. Also Singapore, of course, but is it that's the way that we are doing these techniques, and that we sort of develop these techniques, then maybe that's again a machine learning focus, that if we can learn from data, then we hope that whatever we do here on German cities and highways in the US, that it will also work maybe in South America or Asia or Africa. Do you have any thoughts on this, or is this still maybe too far ahead at the current stage?
I could imagine that at least the perception stuff will transfer to other countries. And everything with respect to prediction, planning, and so on. There are more cultural aspects maybe play a role, how the participants behave. Not sure whether they will.
So more like there's sort of a latent space of behaviors and that you need to explore, but then the techniques will be still quite similar.
It depends on how much you tune your techniques to to the world you live in.
Mhm.
If they work well in a really well-structured environment, like European highways, also, not sure whether they transfer to South America.
But I think at least the OEMs do this, right? They just put the car in all of the countries, and in every country test it will work.
Will be tested.
Yeah. So at least it's awareness for that already.
Yeah, definitely. I mean, you have to make sure that it works everywhere before you start.
But I do certainly think we're focusing on the low-hanging fruits, right? These data sets are from the countries where we expect it to work well, where there's like an economic use case. I think there are other countries which may not see very high levels of automation for another 50 years. Unless maybe in certain roads, you can always pay for highways. So.
But then the technology that we develop can actually be leveraged to quickly deploy in those situations. That's what you.
Yeah, there I'm skeptical.
Oh, skeptical because.
I mean, okay, obviously the data does not transfer, right? We saw that between basically any combination of countries or cities. But even the algorithms might have a hard time in India, for example.
If you read traffic signs, some countries have written traffic signs and to read them and understand the language. So it's completely different technology, I guess.
Yes.
Interesting. Then I think we are now
Just in time.
perfectly in time because here everything goes on time.
One more question from the audience, and we would have time for one more question, maybe.
You said 15 or 50 years?
50.
50.
I mean, until it's really level 5, right?
Okay.
5 years that you mentioned.
That's the dream.
So maybe there's some annotator disagreement here. Okay, I would like to thank first of all our speakers also for this interesting discussion and for their talks. So let's give a round of applause. I enjoyed it very much that we're sort of possible here to have these kind of interactions again, these kind of discussions. So thanks a lot. Also thanks for the audience for showing up and even standing in the doorway. And I think we close the session.
Thanks a lot.
Thank
And
you.
have a nice time, IW.
Yeah, thank you.
Thank you for organizing.